Hello, my lovely students. I really hope that you are doing good. This is the second video of the topic of symbolic logic, okay? Remember that the way of working is you read firstly your working guide, then you come here and you listen to the stuff I have to tell you about the same topic. I hope that these videos could be useful for you. So you read your working guide first, then you come here to my cotorreo, and then later, finally, you go back again to your working guide and you try to solve the exercises or the signatures proposed there, you know. And remember that, well, the final thing of that process is that I will try to have weekly sessions with you in order to solve your doubts and solve any remaining question that you may have, you know. So don't worry. Remember that I'm here for you. That I'm trying to do my best for you. So you are not alone in this logic process that can be difficult in symbolic logic, you know. Uh, Now, we need to remember something that is really important from the previous topic, that is the stuff about the propositions, okay? And for that, I'm going to require the help of my lovely assistant, Donder. So, please, Donder. Okay, as you saw, Donder can be kind of direct and fast. He's kind of a rock star, I'm really sorry. But indeed, as Donder said, remember that a proposition must have the structure of the subject term plus the verb and plus the predicate term. If we don't have that structure, we are not talking about a proposition. Remember that in the last semester we saw and we studied the types of thought, you know, and one of those types was the judgment. Remember that the judgment, or in this case the proposition that is kind of the same, the judgment was when we affirm or deny something about something, in this case about the subject, okay? Now, so in other words, if we don't have the structure, the subject term, the verb, and the predicate term, that is not a proposition. Why is that so important? Because in logic, what can be whether true or false are the propositions, okay, are the statements. For example, imagine this. Let's say that the walls of my studio, okay, the walls of my studio. One question, does it have the structure, the subject term plus the verb and plus the predicate term? No, as you already noted that, no. The walls of my studio is actually only the subject term, okay? So if we say that the walls of my studio, oh, that is true, or oh, that is false, that is meaningless actually. Actually, there is no sense in stating if the walls of my studio is true or false, okay? They are just the wall of my studio. It is what it is, as simple as that. But that changes when we, for example, can say that the walls of my studio are blue. As you can see, they are in fact blue. So in this sense, the walls of my studio are blue is a true statement. Now we have a proposition and a statement. We have a proposition that is the walls of my studio are blue. The walls of my studio is the subject term. Now we have the structure. The subject term are, the verb to be is the verb. And finally, blue is the predicate term. Now we have the structure of the proposition, and now we can state if the proposition is whether true or false. In this case, we can see that that is true. That is really important, guys, because from now on we are going to play among these kind of values, the values of truth or falsehood of the propositions, okay? And this is so important because not only the propositions can be whether true or false, but as well the logical connectives, okay? And that is like the heart and the main stuff today, okay? Before we can start that, one more thing, okay? Remember, this is really important. Remember that we studied as well in the last semester the principle of not contradiction, okay? And remember that the principle of not contradiction says something like an statement cannot be both true and false at the same time and under the same circumstances, okay? So if I say, for example, that all men are good, and I say that that is true, and I say that all men are good at the same time as I said before that that was true, I say now that all men are good is false. It's like, what? I cannot say that, okay? All men are good is whether true or false, okay? We cannot have a middle point, okay? So in other words, the values, the possible values that a statement or proposition can have is true or false. As simple as that. The same happens with the logical connective. What a logical connective can be true or false. We cannot have another possibility. Okay, so let's do this. Okay, well, first of all, the rules of the logical connectives. Okay, I just said that not only the propositions can be whether true or false, but as well the logical connectives, okay? How can we know the value of truth or falsehood of the logical connectives? Well, do you remember, for example, that in the last semester we studied for example, the rules of the definition? Do you remember that, for example, in this semester we studied the rules of the terms, premises of the syllogisms, or for example, that we studied the rules of the first figure of the syllogism, of the second figure, and so on and so on? Well, in this case, uh, each logical connective has a rule, okay? The conjunction itself has its own rule. The inclusive disjunction has its own rule. The exclusive disjunction has its own rule, and so on and so on. So it's like in the same way, each logical connective has a rule, okay? Do you need to learn them? Yes, obviously. I'm really sorry, okay? But I mean, the thing about this kind of stuff is the practice, okay? The practicing. If you practice a lot, and if we are going to do a lot of exercises, I think that the best way of learning something is practice and practice and practice, you know? So if you practice enough, I mean that, or perhaps you won't have to do the sophisticated tool of learning that is called machete, you know? Don't do that, friends. Uh, so yes, you need to learn them. Yes, you need to memorize them. Yes, but I mean, we can do that. Okay. Now, how can we determine the value of truth or falsehood of a logical connective? Well, with the rules. But for applying those rules, we need to know the previous values of truth or falsehood of the variables that are connected by the logical connective. In other words, in order to solve the conjunction between P and Q, I need to know the values of P and Q. In this case, or in this example, I'm going to use the variables P and Q as the same as I did in the working guide that supposedly you already read. If you don't, please go back and read the working guide, okay? Now, uh, remember that these variables, in this case P and Q, represent a statement, represent proposition. Remember that what we symbolize in symbolic logic, in a symbolic into a symbolic language, are propositions. Okay, so in this sense, imagine that P stands for I don't know. All logic students are smart. And imagine that Q represents that all logic exams are easy, that really easy, you know. Well, in this sense, P and Q are representing statements, are representing propositions, and again, remember that a proposition can be whether true or false. So in other words, P can be whether true or false, yes, and Q can be whether true or false, as simple as that, you know. So we need to suppose previously of the logical connective rule the values of P and Q. But that is easy because P can be whether true or false, and Q as well can be whether true or false. So in that sense, we are going to do the same, the following stuff. We know P and Q, okay? We know that P can be whether true or false, and that Q can be whether true or false. What we are going to do in the left side of the chart that we are going to build is to suppose, or it's going to make an arrangement of the possible combinations of the values of P and Q. That is really easy actually, because imagine that we have the first scenario, okay? And imagine that in the first scenario, P is true, okay? And imagine that in the very same scenario, Q is true. Yes or not? Really easy, you know? Now imagine that we have another scenario, the second scenario, that states that P is true. And we already said that P is true and Q is true. Now we need to change now this value because Q can be only true or false. The non-contradiction principle, my friends, do not forget that. So Q in this case must be false. That is another possible combination, as simple as that, you know. Now, in the following combinations, what combinations are still possible? Well, we can say that P is false, and we can say that Q is true. Simple. And now we can say that P is false, and that Q is false. Yes. As you can see, we already did or arranged all the possible combinations that P and Q can have, okay? In other words, it can be possible that the logic students are smart, that is true, and that the logic exams are easy, and that is true. That could be possible, but that could be possible as well that, for example, that the logic students are smart, that is false. No, it's not personal. I'm kidding, I'm kidding, my friends. This is a joke. No, I mean, you are really, really smart. This is obviously kidding, a prank. Uh, it could be possible that, for example, all logic students is false, and that all logic exams are easy. That is true. The worst scenario, as you may see, is that all logic students are smart, that is false, and that the all logic exams are easy, that is false. That will be really, really like something really, really bad, But well, this is not the case. You rock. I love you. Okay, I love you. Yes, I love you. So far so good. At the end, we have in the left side of the chart the possible combinations of P and Q, and in the basis of the logical connectives is this part. Okay, this is really important. If we don't have these parts, we cannot solve each logical connective. So what we should do, we should, for example, divide in columns the logical connective, as I'm doing, and in rows as well, in lines. I know this is really pretty. I know. Okay. Wait a moment. Technical issues. Okay. Yes, I know. Really beautiful, my chart. Okay, really beautiful. Now, in this moment, if you haven't checked already the working guide, please do it. In the working guide, I gave you the rules of each logical connective. They are written there. Okay, so if you need to consult them during while you are seeing this video. Okay, So for example, in the conjunction, remember that the rule of the conjunction is that the conjunction is true when its components, both components of the conjunction are true, okay? When I say component, I'm talking about the variable that there is the variables that are linked or joined by the logical connective, okay? So P and Q are the components of the conjunction, okay? So in that sense, again, the rule is for the conjunction. It is true when both of its components, P and Q, are true. So if P is true and Q is true, the conjunction is going to be true. We can understand that in the other cases, the conjunction is going to be false. So in this case, in the first scenario, remember, P is true and Q is true. One question, how is going to be the conjunction? Yes, indeed. Indeed, true and true. This is going to be true. We have in the second scenario that the P is true and the Q is false. We can say that that is false. P is false and Q is true. The conjunction is going to be false. False on false, this is false. Okay, we already solved the first column of the logical connective of the conjunction, okay? The logical connective of the inclusive disjunction states, well, the rule of the inclusive disjunction is it is false when both of the components of the inclusive disjunction are false. In other words, if P is false and Q is false, the inclusive disjunction is going to be false. As you can see, which is the case that accomplishes that? Yes, indeed, the last one. Okay, so this is going to be false, but the other ones are going to be true. As simple as that. Yes. In the exclusive disjunction or the rule of the exclusive disjunction is it is true, the exclusive disjunction is true when each components, in other words, P and Q, have different values. When P and Q have different values, the exclusive disjunction is going to be true. So in the first case, for example, true and true, those are those different values or not? No, as you can see, are the same values. P is true and Q is true. Therefore, in this case, the exclusive disjunction is going to be false. In the two following ones, we have different values. We have that P is true and that Q is false. And in the third scenario, we have that P is false and that Q is true. In these cases, we have different values, okay? Therefore, the exclusive disjunction in both cases is going to be true, yes? And finally, false on false is the same value, therefore this is false, okay? In the conditional, the rule of the conditional is it is always true except when the antecedent is true and the consequent is false. Remember, we already saw the conditional syllogism, okay? So supposedly you know this. But remember that when we have a conditional statement, for example, the symbolic representation of a conditional statement will be this, actually, P conditional Q. Remember that the part that is previous or that is before the conditional, this is called the antecedent, okay? And remember that the part that goes after the conditional is called the consequent. Okay, well, I know that my letter sucks. You can consult antecedent and consequent in your working guide, okay? So the conditional is always true except when the antecedent is true and the consequent is false. In which of these cases does that happen? That the antecedent is true and the consequent is false. As you can see in the second one. In the second one, in this case, in that case, P is the antecedent and Q is the consequent. And we see that the antecedent in the second scenario is true and the consequent in the second scenario is false. Therefore, this is going to be false in the second scenario. And in the other ones, this is going to be true, okay? The states that it is true, the biconditional is true when both of its components, that are P and Q, have similar values or the same values. As you can see, that is the complete opposite of the exclusive disjunction. So when P and Q have the same values, the biconditional or biconditional is going to be true. For example, in which cases does that happen? In the first one, true and true, and in the final one, or in the last one, final false and false. So this is true, and this is true, because in both cases we have, or P and Q have the same values. In the middle cases, or in the middle scenarios, P and Q have different values. Therefore, this is false, and this is false. And finally, the negation invert the value of the variable, okay? We are separating P and Q, the negation of P and the negation of Q. Do we have a column of values of P? Yes, we have. Do we have a column of values of Q? Yes, we have this one. So what are we going to do? A simple lab as invert for P, or the negation of P, these values, and for the negation of Q, these values. So negation of P, true is going to change into false. True is going to change into false. False is going to change into true, and false is going to change into true. Okay? And finally, in order to finish the negation of Q, we have true, false, true, false. So we are going to invert them. False, true, false, true. Okay? So the negation is actually the easiest one, because it's only it's inverting only the values given already or supposed already of P and Q. Okay? I'm going to solve a few exercises or a few expressions, because you are going to have this kind of similar expressions in your homework, okay? In the signature number, I don't remember if it's 12 or 13, I don't remember, but yes. For example, imagine that you have already given two variables that are A and that are B, okay? Imagine that A and B, imagine that, let's say that A is true and that B is, let's say, true, okay? So for example, if I ask you, A, determine the conjunction between A and B, you are going to say, okay, the conjunction between A and B is A conjunction B. I know that A is true and I know that B is true. Yes, easy, right? Now, if A is true and B is true, the conjunction is going to be true. As simple as that, Now, imagine, well, how can I know that? Because the rule of the conjunction is that the conjunction is true if both of its components, A and B, are true as well, as the case is, Now imagine that I write the same expression, but imagine that I write, for example, imagine that I write, first of all, a negation of A, So I know that A is true. The negation of A is false, is the inversion of this value, okay? In that sense, if I want to determine the value of this conjunction, one question is going to be the same? No, because I know that the negation of A now is false. So the value of this negation of A is false, and the value of this negation of B is, true. So false and true, the conjunction is going to be false. Okay. Okay, that happens, for example, with if we add a negation to a letter A. But imagine that we say, and we erase that, imagine that we say that we don't want a conjunction. Imagine that we want an exclusive disjunction. Imagine that we have A exclusive disjunction B. Okay? If we state the value as with the value that we already have of the A and B, as you already know, the value of this exclusive disjunction is, well, the rule of the exclusive disjunction is, it is true if the value of its components are or have different values. Does or do A and B have different values? In this case, no. Yes. So in this case, the exclusive disjunction between A and B is going to be, as you know, false. Okay. Now imagine that at the end we have some parentheses here, and we have now a negation here. As you can see, the negation is now affecting not only A, but to the whole expression that is contained into the parentheses. So if I ask you, please solve the value of the logical connectives, well, you know that the exclusive disjunction of between A and B is going to be false because they don't have they have the same values, but the negation is going to invert, in this case, the value of the false. Okay, now the negation of the exclusive disjunction between A and B is going to be true. Okay. I'm trying to explain this because you are going to have this kind of exercises, okay? And because this is like kind of the beginning of the following exercises. Actually, the previous chart of the logical connective can be considered already as a truth table. Actually, we already made our first truth tables, okay? Now, imagine that we have more complex expressions of logical connectives and propositions. Imagine that we have more than two variables and we have at least three or four, I don't know. And we have obviously more logical connectives in a single expression. So how can we know if what is going to be true or false, which one is going to be the logical connective that is going to be like the most important one of the expression? Well, we can determine that in two ways, okay? That actually is talking about the same stuff. The first point is the consideration of the jerarchización, the hierarchy of the logical connective. When I say hierarchy, I'm saying priority, okay? We have more dominant logical connectives and less dominant logical connectives, okay? Now, this is something really important. This hierarchy of the logical connective supposes that we don't have punctuation marks in our expressions, okay? If we have punctuation marks, the game changes completely, okay? So again, this hierarchy applies if and only if, okay? If we don't have punctuation marks in our expressions. Punctuation marks, I'm saying, as supposedly you read in your working guide, the parentheses, the bracket, the braces, okay? So in this sense, the most important or the most dominant logical connective is the first of all the biconditional, secondly the conditional, in the third place we have like a tie, you know, between the conjunction and the both disjunctions, the inclusive and the exclusive disjunctions, okay? And finally we have the negation, okay? If you don't have any single punctuation mark, we need to follow or we need to accomplish this hierarchy or this priority of the logical connectives. That means, in other words, that, for example, imagine this supposes as well as I'm explaining that we have more complex expressions, okay? More complex that, for example, A conjunction B, for example, you know? Imagine that we have for example the expression, I don't know, let's say a, sorry, imagine that we have the expression a conjunction b conditional c, okay? If we take a look of the hierarchy or priority of the logical connectives, we can see that the conditional is more dominant than the conjunction, okay? I'm going to write the symbols here in order to be clear. The conjunction, the exclusive disjunction, the inclusive one, and finally the negation, okay? So as you can see, the conjunction is less dominant than the conditional. So this expression is going to be called, or is going to be, a conditional, okay? Wait a moment, conditional, okay? Technical issues, okay. Conditional. Yes? Now, imagine that, I don't know, we add something to this expression. Imagine that we say that A conjunction B conditional C inclusive disjunction D. One question: is that expression still a conditional, or is something changing or not? Well, indeed, that is a conditional. It remains as a conditional because, as we can see, this conditional is now, well, it is still is more dominant than, for example, the conjunction and than, for example, the inclusive disjunction, okay? We have the same hierarchy, okay? We have that the conditional in this sense is winning, okay? Now, imagine, for example, that we change this. Imagine that instead of having this, we say that, I don't know, imagine that we have here and here. I'm going to change both logical connectives, and imagine that we say that this is a conditional between A and B, and we have a conditional between C and D, okay? And imagine that this is joined, this is linked through a biconditional. Now, one question: is this still a conditional? No, exactly, that is not a conditional. This is a biconditional, okay? A biconditional. Why? Because now the more dominant logical connective, the logical connective that has more hierarchy or more priority, is the biconditional, and then the conditionals are, in this sense, secondary connectives, okay? And the same happens with, we can say, we can make a lot of expressions. Let's make another one, a final one. Imagine that, I don't know, we have, imagine that we have, for example, sorry, the negation of A, exclusive disjunction B, conditional negation of C, okay? As you can see, we have three different logical connectives. But again, if we analyze them, we have the negation, we have the exclusive disjunction, and the negation again, and we have the conditional. Again, the more dominant logical connective is still the conditional. So we are going to say that this expression is a conditional, okay? The secondary logical connectives are, well, in this case, the exclusive disjunction and the negations, okay? We are going to learn later in the following topics how to make grades of hierarchization. Actually, we can make grades like this is the most important grade, then the second grade, and finally the negations in the third grade. But wait a moment, because when we see that, we actually going to see the truth table. So wait a moment for that. But the important thing here is that saying that we have hierarchy or a hierarchization of the logical connectives. And as you saw, I didn't use any single punctuation mark, and that is really important, my lovely students. Sorry, because if I use a punctuation mark, it's going to change the in this sense the most important or the most dominant logical connective, and we're going to see that in a moment. And well, finally, this is like the most important part of today's topic, okay? And actually, I want to say something really, really clearly. If we understand this right until this part of the punctuation, my friends, truth tables are going to be really easy. Okay, actually, I think that one of the secrets of the truth table is to understand clearly the use of the punctuation. Okay, now remember that I told you that the use of the hierarchization or the hierarchy or priority of the logical connective supposes that we are not using punctuation marks. But imagine that in complex statements or in complex expressions, we actually need to use punctuation marks because they give to the expression more clarity. Okay. So in this sense, let's say that, for example, we have well, in this sense, parentheses groups or letters, groups, variable, for example, is like a grade again, a gradation again. The parentheses groups, variable, for example, A and B. Brackets groups expressions contained into parentheses. And finally, braces contains expressions contained into brackets. It's like a progressive development, okay? So for example, imagine that we have A conjunction B. We are going to group them with parentheses, okay? Really easy. Well, I'm going to use the same color, that is red, with parentheses, okay? So if we want to use brackets, the brackets are going to group parentheses. So imagine that we need, again, for example, the conditional, and imagine that we say C inclusive disjunction D. So we are going to group them into these ones into parentheses, and we can now group both parentheses into some brackets, okay? Easy, right? Now imagine that this expression that is already contained into these brackets has, I don't know, biconditional with a letter, I don't know, let's say X and Y, and let's say that this is a exclusive disjunction. We can say that this is contained within a parenthesis, and imagine that, I don't know, this is linked by a conjunction with, I don't know, T and W, and T and W are, I don't know, linked via conjunction. Okay, so we can group them in parentheses. Okay, and now we can group these ones into brackets, as we already did in the last one. Okay, I'm going to rewrite this because it could be kind of tricky. This is a bit conditional. Okay, now imagine that now we can group all of these expressions into, for example, the braces, que en español serían las llaves. Entonces, imagine that, well, this is a brace, okay? Imagine that at the end of that expression is a brace. And imagine, my lovely students, that at the end you have a negation here, you know? Now, as you can see, this changes completely the meaning of the expressions. When we use punctuation marks, we are changing because we are making some order into the expression, okay? So imagine that, well, that is like an example of how this group this, and this group this, and blah, and so on and so on, you know? So imagine, well, I'm going to erase this, and imagine that, for example, we have A conjunction B conditional C. This, as you remember, is a conditional. If we take in consideration the the hierarchization or the hierarchy of the logical connectives, indeed this conditional is more dominant than the conjunction. But what happens, for example, if we say that we group B conditional C with a parenthesis, and this is linked? This is the point. When you use a punctuation mark, you are joining two variables into the same expression. It's like a merge, okay? So this is now the B conditional C is a unity, and this unity is linked with the variable A through a conjunction, you know? So in this new case, this is not any longer a conditional. This is now a conjunction. So as you can see, well, I have some company here. My company is this guy. Say hi, man. Say hi to As you, okay, sí, eres bellísimo, güey. Qué pedo. Okay, yes. My lovely partner, man. Okay. As you can see, the use of the punctuation mark changes completely what is going to be now the dominant logical connective. The dominant logical connective changes if we use punctuation marks. Now imagine that if we take so far this example, we have a conjunction, not any longer a conditional but a conjunction, okay? Now imagine that we change this again, and imagine that we merge again. This is the point. The punctuation marks have the function to merge or to consider an expression as a unity. In this case, B conditional C is a unity that now is related, as I told you, with the variable A through a conjunction, okay? What punctuation marks do is to give a new meaning to the variables of the expression, because they are like grouping, they are gathering the expressions, you know. So imagine that now we can group all of these one with a brackets, okay? Now, in the same way as we group B conditional C, and in the same way we said that this is now a unity that we merge B and C into a unity, if we put these brackets, we are merging again, and we are making the whole expression a unity. Now is a unity with these brackets, okay? It's affecting to the whole unity, okay? Now, imagine that we say that this is connected with a conditional to a single letter that is, I don't know, imagine that this letter is D. Only that, you know? So far, the new dominant logical connective is now, which is the logical connective so far in consider this expression. Well, consider that expression, the logical connective, the dominant logical connective is this conditional, okay? But imagine that we didn't use a conditional. Imagine that, I don't know, we said that this is actually a inclusive disjunction. So the new dominant logical connective is the inclusive disjunction. Yes? Now, finally, if we group all of these with braces, the same. This parenthesis merge B conditional C as a single unity, as a single expression. These brackets merge A conjunction B parenthesis B conditional C as a single unity. Okay, now the unity is this bracket. These brackets, the braces is making the whole unit, the whole expression again a unity. Is merging that. Therefore, imagine that now we put a negation here. This negation is affecting to the whole expression, is affecting to what is inside the braces. Therefore, it's affecting to the whole expression. And now, this is not the dominant logical connective is not any longer the inclusive disjunction. Now, the new dominant logical connective is going to be the negation. And I want to finish the video here because that is actually the point, my lovely friends. I wanted to finish the video with this example because, as you remember, the negation is if we don't consider the punctuation marks. Salud, güey. Tornudó, perdón. Coronavirus. Okay, I'm kidding. Yes, dogs cannot. Okay, yeah, okay. Imagine that, well, as I said, the negation is the logical connective that have the less dominance, okay? In that sense, if we don't have punctuation marks, actually the weakest logical connective is the negation. But if we use punctuation marks, as you can see with the parentheses, brackets, and braces, now the final logical connective, the dominant logical connective, is going to be this one, the negation. In other words, why? Because remember that the negation inverts the value of the connective. As you already, I hope that you are seeing this, the negation is going to change. Of course, the meaning is going to change, not the meaning, the value is going to change the value of this inclusive disjunction. Yes? So when we have punctuation marks, such as, for example, parentheses, brackets, or braces, that means that the logical or the dominant logical connective depends on the arrangement of these punctuation marks. Okay, so we need to be really clear about that. We need to be really careful. Okay, and that will be anything for today. As I told you, if you get all of this until this point, I bet you that the truth tables is not going to be a problem for you. Actually, as you will see in the following video of the truth tables, the most difficult part is actually this one, to state the logical dominant connective, because that dominant logical connective is the one that is going to determine the final column of values in the truth tables, you know. So this is, we actually, if we understand until this point, we gain the remaining part of the semester, okay? I hope that you are doing great. I really love you. I really miss you. Donder loves you as well, as you can see. So take care. Goodbye.